This is Geometry Homework Section 14.2, finding areas of parallelograms and triangles. Some of these pictures aren't marked well, so let's just assume that every picture we see is a parallelogram or a triangle, and on the test I will try to do better to make sure that it's obvious. The directions: draw the following, find the area, label your answer. That seems pretty straightforward and pretty bossy. So we have this parallelogram, yeah, or is it yay? I'm illiterate. YEAH says it has a base of 12. Doesn't tell us which base is 12, so we can choose whichever one we want. And a height of 9. The height is perpendicular to the base. To find the area of a parallelogram, it's a base times height. Write the formula out every time you use it. Our base is 12, our height is 9, so that's 96. Supposed to label it. We're using feet, so we're measuring in squares that are 1 foot by 1 foot, 96 square feet. 2, triangle yes with a base of 4.5 and an altitude of 3. So we have the freedom, because it's not obvious, to label these vertices in any way that we want, because it didn't tell us which one is the base. I'm just going to make this the base down here of 4.5. An altitude, which is also a height, goes to a vertex and is perpendicular to a base. We're told that's 3. Area of a triangle is 1/2 base times height. Every time you use the formula, write it out. So using a calculator, we're going to get 6.75 square centimeters, because the unis were centimeters. Number 3, rectangle. Rectangle is still a parallelogram. Directions say to draw a picture. It's 4 by 8. Area of a parallelogram is base times height. Base and height are 8 and 4. You could make an argument that either one is either one. The units are square feet. Cool. Number 4, find the area of each, label your answer. So once again, we're going to just assume every picture is a parallelogram or a triangle, because these are not properly labeled. That's a mistake on my part. I apologize for that. To find the area of a parallelogram, you take the base times the height. Base and height are perpendicular to each other. So this, which is not part of the parallelogram, must be the height. And the base is the length that is perpendicular to that, which is the 6.7. The 6.14 isn't used, and the only way that it would be used is if we had this height. We would use this height and this base, but we don't have that. Product of 6.7 and 5 using a calculator is 33.5. The unis are yards, so it's square yards. Number 5 is a triangle. Area of a triangle is half the base times the height, because this is half of a parallelogram. Base is any side, but the height you choose has to be perpendicular to that base. So you could say it the other way, is round as well. If you know what the height is, then you have to use the base that corresponds to that. So we got 1/2 of 12 times 3.7, which my calculator says is 22.2, and our unis are square miles. Number 6, this is a parallelogram again, a specific type, a rectangle. Base times height. Base is 8.4, height is 3. Remember that the base and height are perpendicular to each other. Cool. 7. Oh, interesting. We are going to use this height and this base that corresponds to it. area of parallelogram, base times height. But we don't know what the height is. What we do know is that this little fella is a special right triangle. The hypotenuse is the short leg times 2. I almost wrote that wrong. Which makes the short leg 5, which makes the long leg 5 square roots of 3. So the base is 16, the height is 5 square roots of 3, 16 times 5 is 80. Let's just leave it as an exact answer. And the units we had here was meters, so the area is going to be square meters. If that blue triangle took you by surprise, I would stop this right now and I would go review special right triangles. Number 8, this is straightforward. Area of a triangle is half base times height. Height is 6, the base is the one that's perpendicular to that, so it's half of 6, scratch that, it's half of 12 times 6, which is going to be 36, and the units is square miles. Number 9, this is interesting, I think it is. To find the area of the triangle, it's half the base times the height. Well, if this is the base of 15, then the height has to be the side that's perpendicular to it, and we don't know what that is. Fortunately for us, we have trigonometry. Yay! Tangent of 34 degrees, we'll call this the height, is the opposite leg over the adjacent leg. So that's the height over 15. I multiply both sides by 15. Put this in my calculator, make sure it's in degree mode. To 2 decimal places, I get 10.12. I multiply these three fellas together, I get 75.9. The unis were kilometers, so the area is square kilometers. Number 10, these special right triangles just won't go away, will they? If you didn't know your special right triangles, you could also figure this out by saying this is x and this is x. Use the Pythagorean theorem. It would not do that. Another thing that you could do is knowing your special right triangles. This is the short leg times the square root of 2, which must mean if you divide both sides by the square root of 2 that 9 is the short leg. There are 2 short legs. Gets us an isosceles triangle. So the area of the triangle is 1/2 the base times the height, and the base and the height are perpendicular to each other. They're both 9. That's half of 81, which is 40.5, and the units were inches, so it's square inches. Number 11, if we call this the height, because it's perpendicular to the base, in a parallelogram, opposite sides are the same length, so if that's 10, this is 10. So we're saying that the base here is 10, and the height, we don't know. Well, we could find it using this right triangle. It's not special, but using 58 degrees, we could say sine of 58 degrees is the opposite leg, h, over the hypotenuse of 7. To get h by itself, multiply both sides by 7. Put that in your calculator, and you're going to get 5.94 to 2 decimal places. Then to find the area of the triangle, it's 1/2 the base times the height. The base is 10, the height is 5.94. That is 59.4 square meters. Number 12, this one is straightforward. Area of a triangle is 1/2 base times the height. Base and the height are perpendicular. So it's 1/2 of 4 times 2.7. So the area of this triangle is 5.4 square feet. My little triangle is dancing with me. It was purely an accident, and yet it was beautiful. Find the missing measurement. Round to the nearest tenth. That's 1 decimal place. So the area of a parallelogram is the base times the height. Do we know the other parallelogram? We sure do. It's 72.9. Do we know the base? No, we do not. We'll just call that B. Do we know the height? We sure do. It's 6.6. If you divide both sides by 6.6, you're going to get 12 as the base, and we're supposed to use proper units, so it's 12 kilometers. Number 14, area of a parallelogram, base times height. This is actually a rectangle, which is a specific type of parallelogram. Do we know the area? We do, 123.2. Do we know the base? We don't. Do we know the height? Yes, it's 11. If you divide both sides by 11, you're going to get 11.2 units is yards for the base. Excuse me while I take a drink of water. Goes down smooth. 15, area of a triangle. Half base times height. Base and height are perpendicular. We know the area is 28.1. We know the base is 7.3, and we don't know the height. Half of 7.3 is 3.65. Notice the direction said to round to 1 decimal place. This isn't our answer yet, so I'm not rounding at all yet. I don't round until I get to the final answer. If I then divide both sides by 3.65, I got 7.7 feet for the height. 16. Height, base. Area of a triangle is 1/2 the base times the height. Say the base, we don't know, that's the question mark. The height we know is 9.7. We also know the area of the triangle is 47. Half of 9.7 is 4.85. Once again, I'm not rounding that, I only round the final answer. And then if I divide both sides by 4.85, I'm going to get 9.7 yards is the base. Once again, the direction said round to the nearest tenth for your final answer. All right, number 17. This looks fun. Area of a parallelogram is the base times the height. Hey, we know the area is 40. Base and height are perpendicular. We're going to have to multiply this stuff out and factor it. If I multiply the right side out, I'm going to get x squared plus 3x. If I subtract 40 from both sides, I get x squared plus 3x minus 40. This trinomial factors into two binomials, x plus 8 and x minus 5. How do I know that? Because 8 plus a negative 5 is positive 3. 8 times a negative 5 is negative 40. Set each factor equal to 0, because this potentially apparently has two answers. Now let's see if both of these answers make sense. If I put a negative 8 in for the height, and a negative 8 in here, I'm going to get negative 8 times negative 3. Yes, I'm sorry, negative 8 times negative 5. Yes, that makes 40, but it makes no sense for these lengths to be negative. So this answer, we're saying, doesn't make any sense. Does x equals 5 make sense? Because sometimes none of these answers work. This height would be 5, this would be 8. That is perfectly appropriate. So we're saying that x is 5 feet. Make sure you include your unis. Number 18. This is very similar. Area of a parallelogram. Base times height. The area is 65. Base is the sum of x and 3. The height is the difference of x and 5. If you multiply that stuff out on the right using the distributed property, FOIL, box method, whatever you kids are calling it these days, we're going to get x squared minus 2x minus 15. If we subtract 65 from both sides to get all the terms on the same side, we're doing this because we have different exponents for the variables, which means we're going to have to factor. Anytime it's a trinomial and your lead coefficient's 1, right here is 1, it's the easy type of factoring. You need two things that multiply to get negative 80 and add to get negative 2. Well, that's going to be a negative 10 and a positive 8. Set each factor equal to 0. And we got x could be 10 or it could be negative 8. Don't assume the negative one's the one that's wrong, even though that's the one that's wrong for this one. If I put a 10 in here, 10 minus 5 is 5. 10 plus 3 is 13. That's fine. If I put a negative 8 in here, we get negative 13 and negative 5. That is not fine. This one doesn't make sense. So x is 10 feet. Got some algebra review. This would be important because we haven't done tons of algebra. I mean, we have, but there are holes in what we've done from what you've learned from last year. To solve an inequality, you solve it the same way you would solve an equation, only if you multiply or divide both sides by a negative number, you change the inequality sign. I'm going to distribute the 2 and get 6x minus 4x is less than 35. That's not true. I'm going to get 6 minus 4x is less than 35. That's better. I'm going to subtract 6 from both sides and get negative 4x is less than 29. Now I'm going to divide both sides by a negative 4. Since I'm dividing both sides by a negative number, the inequality sign changes direction. That is about, it's actually exactly negative 7.25. So since it says x is greater than, it's an open circle at negative 7. Let me change the color. It's an open circle at negative 7.25. It's about there. Greater than means going to the right on the number line. That's bigger than I really want it to be. There we go. So it would look something like that. This one below, let's figure this little fellow out. Let's get all the x's on one side. Let's get them on the left, let's say. We would get negative 2x plus 5 is greater than or equal to 8. Subtract 5 from both sides. We get negative 2x is greater than or equal to 3. And then if we divide both sides by a negative 2, we get x is less than or equal to a negative 3 halves. Since it says less than or equal to, it's a solid circle. Negative 3.5 is negative 1.5, if you prefer. That is here. Closed dot. Less than means we shade to the left. So it looks something like this. Just to graph these, your choices are to get it in slope-intercept form or to find the x and y intercepts and graph it that way. Essentially, you just need two ordered pairs in order to graph a line. I'm going to put this first one in slope-intercept form. I'll probably do both of them that way. Then I divide each term by 3. I get negative 2/3 x minus 3. So the y-intercept is at negative 3. And the slope tells me from that point I go down 2 and to the right 3. And I put a dot. If you only need 2 points to make a line, why do I often do more than 2? Just going to make your line more accurate, that's why. I could also go up 2 and to the left 3. I'm going to sneeze, I'm sorry. Oh, I'm so sorry. It's all over the screen. It probably got on you. I probably passed Corona to you. Sorry. This is 0, -3 is the y-intercept. Let's do this one below it. It's a little different because it says it's an inequality. Let's get it in slope-intercept form. I just divided by a -2. The inequality changes direction. My y-intercept's -5. My slope is 2 over 1. I go up 2 and to the right 1, up 2 and to the right 1. Since this says greater than or equal to, the equal to means this is a solid line. If it just said greater than, it'd be dashed. Notice it says y is greater than. Where are the y's greater? Are the y's greater above or are they greater below? They're obviously greater above. So this gets shaded. You don't need to like really go nuts on the shading. You can just do something like this if you want. I went nuts on the shading. Please label your y-intercept. Multiply this out. So we'll take our time and do this. We got to multiply the 2x times the x, and the 2x times the 3. That's going to be 2x squared plus 6x. We got to multiply -5 times x and -5 times 3. The middle two terms are often like terms. We get 2x squared plus x minus 15. Factoring is doing this backwards. And this fella right here, not the easy type, we're going to split the middle term and factor by grouping. To do that, we need to split this -7x apart. We need two things that multiply to get 6x squared times -5, which is -30x squared. We need the same two numbers to add to get -7x. What do you think those numbers might be? How about a -10x and a +3x? That adds a -7 and it multiplies a -30x squared. The order in which you write these does not matter. When you group these together, I suggest not to use parentheses, but just group it like this. It will help us avoid some sign errors. GCF of the first group, we just split the middle term. Now we're going to factor by grouping. GCF of the first group is 2x, leaving us with 3x minus 5. GCF of the next group, there doesn't appear to be 1, which means the GCF is in fact 1. Now we got two terms. One term, two terms. What factor do those terms have in common? Well, they have a 3x minus 5. That is the GCF of those terms. What are we left with? We're left with 2x plus 1. That is a fully factored, my friends. Well, that concludes this homework, 14.2. Hope you enjoyed it.